Hello and welcome to today's lesson. To get access to our starter pack files such as blueprints, technical primer PDFs, native CAD files, as well as exclusive master courses, join our community on Patreon at patreon.com/ArielCad3D. You'll find the link in the description below. Going to change that. So one more thing regarding the U-bolts, there is usually a plate either at the bottom or at the top here where they go through. So that plate is supposed to keep them from moving, say in the lateral direction. So we should have a plate here. This one is going to be mirrored on the other side. Mirror. And in this case, we need to bring in that axis that was in the middle. Let's go to differential. We had axis system 1. Double click on that. Axis system 1. Publication. Then I'm going to copy back to our part and paste it. As a result, with link, show it. And I'm going to use that to create a mirror. Go back to part body, select mirror the current object using this CY plane. All right. So we need a plate. We can sketch the XY plane. That's the ZX, XY plane. And basically it's a rectangle. Let me start with an axis that is coincident with this y-axis. Then instead of a rectangle, I can have an open profile. That goes like that. I can have another axis which is at a distance of, we said it should be 20. So that's in the middle like that. And then I'm going to make sure that these two lines are symmetrical about this symmetry. Like so. Bring it close like that. And it got 4 holes where these ribs are passing through. Maybe make it wider. Let's give this a length 55. These holes are 5 millimeter in diameter. Obviously, they can have a tolerance, but this time around we're not going to define the tolerance. So the diameter is 5 millimeter. We're going to select it and mirror it using this. Then we're going to select the entire geometry, the 2 circles and the 4 lines, and you're going to mirror them using this axis. I don't think we need to add corners, but if we were to do it, I can select all 4 points and add a slight corner. Of 5 millimeters. Exit. Now we want this to sit on this face. Let me hide this, we don't need it anymore. If I want it, if I want precision, I might have to publish the top sketch. We go to leaf springs, real leaf blocks, got pad 15, sketch 24. Oops, sorry, undo that, double click. Sketch 24, okay. Going to tools, publication, sketch 24. Tools, publication. Go back to our part. You can do that by double clicking on any current part. Going to copy and paste it here. As a result with link so that any adjustments are going to reflect. And using this, I can create a reference plane. I can say I want through a point, which is the XY plane, through that point, and then hide. Then I can now create a pad. The first limit is going to be up to plane, that plane. In fact, you can have another up to plane and selection. You can create a plane and offset this, offset from plane, and give it a thickness if it is 5 millimeters, like that. Then the sketch is this sketch. That's how you can specify for precision. Going to give it a material like that. So this plate holds them together to prevent those shear and translational forces from shaking it. I'm thinking of adding some material to this. Let's pull it out a little bit. Let's make this to be 60. Much better. Is there a reason these two are not aligned? Yes, there is. So this is actually, the circle is not supposed to be at the center. What distance did we give it? Was it 17.5 from this? The distance between this and the center of the circle, I might have to move it first. Oh, delete it. Delete the 4 circles. This, the diameter is 5, just like before, but now the distance between the center and this section is 17.5. Is that correct? Then we mirror it like that, and we select these two, mirror them using this axis exit. Perfect. Now they coincide. And then we can secure them. As I said, we're going to insert a new body. This is going to be a vanity feature once again, and it's going to be, let's call it a bolt. Let's make it a bolt. Define in work object. So we are sketching this ZX plane. Should I hide this? But then I won't see if I hide it. Select profile. Or maybe make it into an arc. Not really, I don't want it to be like that. Let me select like so. And then we know that the shaft diameter here is supposed to have a radius of 7.5. Then you can trim off. I don't know if you can see what I'm creating. See that profile? Let's define the distance between that, or the head radius, to be 15. This line right here The width can be 10. The distance between the tip or the overall height can be 14 or 15. We might have to push our geometry, like I said here, we might have to push it out for another 2.5. You see the 2.5 that is going inward, we will translate it outwards so that it starts at this section and the entire length is going to be 5 millimeters. So we can define our distance from this axis to where this begins to be 5. But as I said, we are going to hammer it. We are going to reduce its thickness in real time. We would hammer it down to flatten it, and then we would use this to secure it. But let's just assume for now. So we are saying we need to translate. Let's go to part body. We need to translate. We're going to translate everything. No. Let's just leave it. We should have done it before we even added this plane. So back to the bolt. Create a shaft. There's the profile. The axis is going to be this x-axis. So we're going to assume we've got a feature like that that is securing it down. Maybe not black. Black is too prominent. And just like the others, you can use a polygon. And define the radius from this line to be 15. Then add any other material, any other profile. I mean, it could be circular, it doesn't matter, because we are creating a pocket. And then we create a pocket. Wait, what was the diameter here? This is 15. Okay, I know. Sketch 7. This is not the one that is supposed to be 15. It is the distance from this point. This is supposed to be 15. Okay. And this will probably be secured by a cotter pin or something. Nevertheless, if you are designing for a company, they will have specification, they will have exact means that you're going to secure this feature. I'm gonna go to the part body and fix it because I'm never satisfied with something that is not making me happy. We already have our planes, so we can define our pad again. We can delete that pad. Pad 1, do not delete the parents. We still need sketch 4. I'm going to delete the mirror, and first I'm going to select the rib and translate it in the X component for 2.5. 2.5, we've cleared the distance. Perfect. Then we can now mirror this using the ZY plane right here, and we can create our pad using this sketch, and we're saying limit 1 is up to plane 1, limit 2 again up to plane 2. Select OK. Now I'm happy. Now I'm happy. And then you can create a pattern for this feature, or you can copy. Where is the shaft? You can sketch on the XY plane and just create 4 points. Create a point along this. That is a distance of 40. Like that. I don't know if we need to create an instance here, but nevertheless, a point at the center like that. Then click on Shift. These 2 points, we are going to mirror them using that plane. And the points should be construction elements. I mean standard elements, not construction elements. So you should see them when you exit. So I'm going to create a user pattern for the current solid positions. No. Where are we? In the bolt. Sketch 8, cut and paste it in this user pattern. These are the positions. This is not good. I need these ones to be rotated. Edit the sketch. Just delete these points on that side. But the problem is if I create a user pattern here, I might not be able to. I was trying to avoid that in the first place. So what is the best solution we can do? I can just delete that sketch. Instead, I can create another axis system here. By going to GSD, and translate this. Alternatively, you can translate a point. Where are we? Instead of moving to the GSD, you can translate a point using coordinates. The axis system is this one. Everything else needs to be 0 except the y component, which is going to be 40. Insert axis system right there. Then we have two sketches, one for the shaft, one for the pocket. Copy and paste. But the new sketches, we are going to change sketch support to this. We were supposed to reverse. X-axis is a line from this point and direction. From that point, okay. Instead of using, hold on, edit, line 1, point and direction. Why is line 1 being used in an update cycle? That doesn't make any sense. Close. Let me delete this axis system. Instead, create a line, point and direction. Direction is the X component. And then insert an axis system. Then X is going to be this line, but I'm going to reverse it. Like that. Okay, problem solved. We can now select sketch 10, change sketch support to this. Sketch 11, change support to that. Then we can create another shaft and another pocket. Okay. So we have two geometry which we can now mirror using this CY. And now they are facing the right direction. That's good. We can hide the axis systems and the point. And you've got the U-bolts for the rear section. So sometimes this plate can be placed at the bottom section, or it can be placed at the top section. So if you're going to place it at the bottom section, make sure that that distance we defined, 2.5, you're going to add this 5 millimeter thickness, so it will be now 7.5, and then you can drop this down or you can put it upwards. So they are secured like that. I hope you've learned something from this lesson. This securing mechanism, probably not the best. Okay, probably not the best, I will admit that. But if you're working again for a company, you will definitely have the specification. Or if you're an engineer, you already know which is the best method for that. Mine is to just show you how to create the CAD systems.